Here is our last example on energy methods. For those who are new in my channel, and if you like what I'm doing, please share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to keep me going and refreshed. Determine delta B or deflection at B by virtual work method and the deflection and slopes at D by the Castigliano's second theorem. Moment of inertia of portion ABCD is I, while that of DEF is 2I and E is constant. So first, for deflection at B by virtual work method. So considering AB, because the load is at the center, then the reaction at A, vertical reaction at A and just to the left of B would be 15 and 15 as shown. So not shown how to compute this because you know already how to do that. Then by action reaction, we have 15 down at B just to the right, kilonewtons. Then considering BCD, summation moment about D equals 0. So we have reaction at C times 4 plus 90, then minus 15 times 7, minus 20 times 3, 1.5 plus 4 is 5.5. So 20 times 3 times 5.5. Then R sub C is equal to 86.25 kilonewtons as shown. Then summation forces Y equals 0, assuming vertical reaction at D just to the left is upward. So negative 15, negative 20 times 3 plus 86.25 plus vertical reaction at D just to the left equals 0. So D sub V is negative 11.25, so meaning it is downward as shown in the figure. So by action reaction, just to the right, 11.25 kilonewtons. Then considering DEF, summation moment about F equals 0 to solve for RE. RE times 6 plus 11.25 times 11, then minus 15 times 11 times 5.5. Then RE equals 130.625 kilonewtons as shown. Then RF is 23.125. So you just solve for RF by summing up moments about E or summation forces Y. So I will leave that to you to solve that. That's a basic way of computing the reactions. Then let's select our sectioning. So X, then BC. Take note, these are internal hinges. So at the internal hinges, if we consider forces just to the left, that will be our reference. So all forces to the left of that reference hinge will not be involved anymore in the moment equation. You just take note that when we have internal hinges, that will serve as the reference. Then for this section here, this section, and for this section we put it just to the right. So X, and that's the last section. There are so many sections. Then for the virtual forces, so we have the option to apply the unit virtual load just to the left or just to the right of B. So let's apply it just to the right of B. You can also put it just to the left of B. I have a purpose of putting it just to the right of B. So therefore, if we do the free body diagram of AB, if you sum up moment about B, the reaction at A would be 0. So reaction at A is 0. Vertical reaction at A times 4 plus nothing equals 0, so that's 0. So meaning to say moment equation due to virtual forces at this section should be 0. So that reduces the number of equations to be evaluated. So considering BCD, this should be 1.75 downward because the equation is reaction at C downward, summation moment D, times 4 equals 1 times 7. So 1 times 7 over 4 is 1.75 downward. Then summation forces Y, because this is downward, this should be 0.75 upward. Then by action reaction, 0.75 downward. Then for DEF, summation moment about F equals 0. So this should be 11 over 8. Reaction times 6 equals 0.75 times 11. So 0.75 times 11 divided by 6 is 11 over 8. And finally, you may sum up forces vertical to solve for reaction at F, and it is 5 over 8 downward. So that 3/4 plus our 11 over 8 minus 3/4 or 0.75 minus 5/8 equals 0. So those are the reactions due to this virtual force at B. So let's now apply virtual work method. Remember the formula: deflection equals integral of big M due to actual loads, small m dx over EI. So EI delta B equals integral 0 to 3. Let's start with this section here because reactions here would be 0 or moment would be 0 there. So we have negative 15 times x, negative 20 times x over 2, or negative 10x squared. That's for moment at this section, considering forces at the hinge as a reference. These are not included anymore because the reference is a hinge. This is a point of discontinuity for moments. Then in this section, the moment is just positive 1 times x as shown. Then for the next section here, so we have plus integral 0 to 2 of 86.25 times x minus 15 times 3 plus x minus 20 times 3 times 1.5 plus x. 20 times 3 is negative 6. Negative 20 times 3 is negative 60. Again, negative 20 times 3, 1.5 plus x. So negative 60, 1.5 plus x. And moment in this section here is positive 1 times 3 plus x, then minus 1.75 times x, small m, dx. Then we proceed to this section here. So plus 23 point integral 0 to 6 of 23.125 times x, 0 to 6, then minus 15 times x times 6 over 2, or minus 7.5 x squared, then minus 5/8 of x, and divided by 2 because the moment of inertia of DEF is 2 times that of ABCD. Then in this section here, considering forces to the right, plus integral 0 to 5 of 23.125 times 6 plus x plus 130.625 times x minus 7.5 times 6 plus x quantity square, or 15 times 6 plus x times 6 plus x over 2, so that's why minus 7.5 6 plus x squared. Then for virtual forces, 11 over 8 times x minus 5/8 of 6 plus x, this one. Then everything divided by 2 because the moment of inertia is 2. Then lastly, for this portion here, take note we haven't yet included this, and the moment of inertia is just I. So we have negative plus integral 0 to 2 of negative 11.25 times x. Then for virtual forces, positive 0.75 times x. So that's it. So using your calculator there, actually I use SMath solution software in evaluating the integral here. So the value of this integral is negative 337.5, but in your case, by the way, Because high-tech calculators are not allowed, you have to evaluate this individually in your Scratch by simplifying first inside before you evaluate, so that it's easy for you to evaluate the integral. For the second term, this is negative 562.5. Then this one, 239.0625. The value of the integral here, 260.6719. I want you to verify this by pausing the video and try to evaluate this. Then finally this one, this negative 22.5. So combining, the value of delta B therefore is negative 237.5 minus 562.5 plus 239.0625 plus 260.6719 minus 22.5. So delta B is equal to negative 419.766 over EI, which verifies the answer using the three basic methods. Then for slope, just to the left of D by Castigliano's second theorem. So we apply a positive couple C at D just to the left as shown. Then let's evaluate the reactions. So take note that if we consider AB, the reactions will be 15 and 15 because they are not functions of the couple. The partial derivative of the moment equation with respect to these sections would be 0 because these reactions are not functions of the couple. We will only evaluate portion of the section where the moment is a function of that couple, because there is definitely partial derivative of that moment equation. So likewise, by action-reaction, that's also 15. And this time, couple is involved in computing this reaction here. So if we sum up moment about C, reaction, assuming upward, times 4, just concentrate on the contribution of the couple because the reaction due to real loads have been determined already in this method, in this procedure. So reaction at C times 4 equals couple. Therefore, reaction here is 86.25 plus couple over 4 or plus 0.25 of couple. Then summation forces Y in this portion, then this should be downward 11.25 plus C over 4 as shown. Then action reaction 11.25 just to the right plus C over 4. So just concentrate on couple over 4. So summation moment F considering DEF, reaction at E times 6 equals C over 4. Just concentrate on C over 4 times 11. So the reaction here would be 130.625 plus something. So if we solve for this reaction first, summation moment E equals 0. So reaction at F times 6, reaction at F times 6, that's counterclockwise equals clockwise equals C over 4 times 5. So C over 4 times 5 is 5 over 4 divided by 6, so that's why we have 5C over 24. Then you may sum up forces vertical if you want, or you sum up moment about F. So reaction at E times 6 plus C over 4 times 11 equals 0. So reaction here would be 130.625. So C over 4 times 11 is 11 over 4 negative. After transposing, divided by 6, so negative 11c over 24. So negative c over 4 times 11, then divided by 6, so it's correct, negative 11c over 24. Or summation forces y c over 4 plus 5c over 24 minus 11c over 24, that should be 0. So anyway, that's statics. So we begin by evaluating not this section here, but rather in this section. So this should be the starting 0 to 2, but we include these forces also. So EI theta d just to the left equals integral from 0 to 2 of 86.25 plus c over 4 times x minus 15 times 3 plus x minus 60, 20 times 3 times 1.5 plus x, or 60 times 1.5 plus x. Then the partial derivative of c over 4 times x is x over 4 dx. Then that is this section here. So we proceed to this section now. Plus integral of from 0 to 6 of 23.125 plus 5c over 24 times x minus 7.5 x squared divided by 2. Then derivative is 5x over 24 dx. Then in this section, plus integral 0 to 5 of quantity 23.125 plus 5c over 24 times quantity 6 plus x plus 130.625 minus 11c over 24 times x minus 7.5 times 6 plus x squared. Then partial derivative of this equation 5 over 24 6 plus x, then minus 11x over 24, then everything is divided by 2 because the moment of inertia is 2i. And finally, in this section here, we have couple integral from 0 to 2 of couple minus quantity 11 over 25 plus c over 4 times x, then partial derivative is 1 plus x over 4. Then moment of inertia is 1, so that's why we do not divide everything by 1. So take note that c is just invented, so prior to integration this is set to 0. So 86.25x minus 15, 3 plus x minus 60, quantity 1.5 plus x times quantity x over 4 dx. So that's the expression to be evaluated. So the value of this is negative 60. So this is set to 0. The value of the second integral is negative 79.6875. The value of this part, so this is ignored. So after simplification, you stop the video, then simplify that, verify if the value is negative 87.8906. And finally, this is 0, 0, negative 11.25x times quantity 1 minus x over 4 dx. Integral from 0 to 2, the value is negative 15. So combining, so we have theta d just to the left is negative 242.578 over EI. So next we proceed to deflection at D. So for the deflection at D, we apply upward force P. We have the option to put it be to the left of D or to the right of D. So for simplicity, just like slope just to the left of D, let's apply it just to the left of D. But you can also apply it at the hinge center D or just to the right of D. The effect is the same. So let's apply it here so that the reactions here, it will not be affected by P, so it's still 15 and 15. So action reaction 15, while the reaction here will be not a function of P, because if we sum up moment about D, the moment arm of P about D is 0. So this is still 86.25. So therefore, the moment equation up to this section is not a function of p. So we drop all the integrals for these 4 sections here. So we proceed to this section. So if we have p here, then the reaction here was 11.25 downward, but because there is p here, so it should be 11.25 plus p downward. So action reaction 11.25 p upward. Or if you sum up moment about c 0, so just consider p. So reaction times 4 equals p times 4. That's why you have 4p over 4 is p. So here at F, summation moment E is 0. So reaction at F times 6 equals p times 5. Reaction at F times 6 equals p times 5. So 5, 6p. So the reaction here due to actual loads was 23.125, then plus 5b over 6. P times 5 divided by 6, so 5b over 6. Finally here, you may sum up forces vertical or summation moment at F. So if for simplicity, summation forces vertical. So therefore, P plus 5b over 6 is 11p over 6. So therefore, the reaction here would be due to actual loads, then minus 11 over 6p. 130.625 minus 11 over 6p. So we begin with our integral here up to here. So we'll have 3 integrals only because up to this section here, everything is not a function of b. So ei delta d is equal to integral of from 0 to 6 of 23.125 plus 5b over 6 times x minus 7.5 x squared. Then partial derivative is 5x over 6 over 2. And this section plus integral of quantity 23.125 plus 5b over 6 times 6 plus x plus quantity integral of 130.625 minus 11p over 6 times x, then minus 7.5 times quantity 6 plus x squared. Partial derivative would be 5 over 6, 6 plus x minus 11 over 6x dx divided by 2. Then finally in this section here, the integral would be integral from 0 to 2 of b times x minus 11.25 plus b quantity times x. Then partial derivative would be 0 because we have bx minus px is 0. So there's no p here. So partial derivative would be 0. Luckily, we have only 2 expressions. So prior to integration, take note p is 0. So the integral of the first term is negative 318.75. So this is set to 0, and in your scratch, simplify, then integrate. The value is negative 351.5625. That is 0. So delta D can now be evaluated. It is equal to negative 670.312 over EI. Then finally, for slope just to the right, so we apply positive counterclockwise couple C just to the right of D as shown. So if we isolate AB, again, the reactions here are not affected by C. So it's still 15, 15, and 15 down. If you sum up moment D, so this is still 86.25. Then same with the preceding up to this section here. They are not functions. Moment equations are not functions of couple. So therefore, we proceed to this section here. Reaction at F, summation moment about D. reaction at F times 11 times, so this is, by the way, 11.25 only, not a function of couple, 11.25. So if we sum up moment about E, because this is not a function of couple, so RF times 6 plus couple equals 0. So therefore, the reaction here is 23.125 minus couple over 6. Then if we sum up moment about F, reaction times 6 clockwise equals couple. So therefore, this is 130.625 plus couple over 6. So that's it. So the moment equation here would be not a function of couple anymore because the couple is just to the right. So we only have two integrals in this section and this in this section, just like this. So therefore, EI theta d just to the right equals integral from 0 to 6 of quantity 23.125 minus couple over 6 times x minus 7.5 x squared, then partial derivative negative x over 6 over 2 dx. Then in this section, plus integral 0 to 5, this section, considering forces to the right, of quantity 23.125 minus couple over 6 times 6 plus x plus 130.625 plus couple over 6 times x minus 7.5 times quantity 6 plus x squared. Then partial derivative is negative 6 plus x over 6 plus x over 6. Or simply negative 1. This is negative 1 if you simplify, and divided by 2 because the moment of inertia is 2. So that's it only, because this is now not a function of couple. So prior to integration, c is 0, so the value of the integral here is 63.75, while here the value is 85.9375. Combining, theta d just to the right is equal to 149.688 over EI. So that's it for this solution. It's very long, but take note that it's a matter of statics and application of the Castigliano's second theorem. And of course, this is tedious if you don't have a high-tech calculator. So it is not recommended when we are not allowed to use high-tech calculator. So we'll just solve simpler problems because those problems are practical and possible in the board exam. I just include this because I included this in the preceding methods to verify that the results are the same. And secondly, this will challenge those who want to master deflection methods. And if you can follow the solution, then it's a guarantee that you have understood the principles.